Good day everyone, I am Zian B. Maloya from BEd 2A and my topic for today is Introduction to Solving Missing Lines in Isometric Projection. The main points to be discussed is three surfaces types of principal, inclined, and oblique, missing line problems, general procedures, and example. Let's start with the three surfaces types. The first type is surface type A, also called a principal surface, which is used in technical drawing and orthographic projection. The red shaded area represents surface A. This surface is shown in cruise eyes in one of the orthographic views, the top view in this image. The drawing shows three standard views: top view, front view, and side view. These views work together to show all details of the 3D object. In the top view surface, A appears in its true size, a full rectangle. When projected to the front view and side view, this same surface becomes only a line, because the viewer is looking at the surface edge on. As you can see in the text presented, true size in one view, edge or line in other two views. This means flat plane becomes a line when viewed from the side. The numbers mark the corners of the surface. They help track how the same corners appear in each view. For example, corner 1 in the top view corresponds to corner 1 in the front view. Corners are paired to guide the projection. As you can see, the diagonal line on top is a meter line used to transfer measurements correctly between the top and the side views. It ensures that the projections between views is aligned properly. Now for our next slide, we have surface type B, inclined surface. The red shaded surface is surface B. This surface is inclined, meaning it is not parallel to any of the main planes, front, top, or side. Because it is tilted, it never shows its true size in any standard view. Inclined surface appears as a slanted shape in two views. The surface has a characteristic shape in the front view and the side view. These shapes are not the true size of the surface. They are distorted because of the tilt. In third view, it appears as a line. One view will show the inclined plane as only straight line because you are looking at its edge. As you can see in the image, the top view shows the line representing the edge of the inclined surface. These labels represent the corners of the inclined surface. They help you trace how the same point appears in each view. For example, corner 1 in the front view matches corner 1 in the side view. Corners shift position in the projections because the surface is tilted. There is also the meter line, and we have tackled that earlier, and again it is used to correctly transfer measures. This makes sure the projections align accurately. And now for the last type, it's called surface type C, oblique surface. An oblique surface is a plane that is not parallel to any of the major planes, front, top, or side, and not perpendicular to them either. Because of this, an oblique surface always appears distorted in all three views. The red shaded surface represents surface C, the oblique plane. It is shown in three views. The corners 1, 2, and 3 mark the edge of the surface. These same corners are projected into each view. The text says, characteristic shape in all three views, but true size in none. This means the oblique plane never appears in its true size in any view. Instead, each view shows a slanted, distorted version of the surface. Why? Because the surface is tilting in two directions, not just once. These numbers represent the corners of the surface. They help track how each point appears in each projection. For example, point 1 in the top view corresponds to point 1 in the front and side view. This helps engineers understand how the shape transforms between views. So question, in which views could you get the true length of edges of this oblique surface? Although the surface itself never appears in true size, the edges of the surface may appear in true length if one of the views, for example, the edge 1 to 2 might show the true length in either the top, front, or side view, depending on orientation. You determine this by checking which view shows that edge not foreshortened, a straight, undistorted line. Next is the missing line problem. The goal is to reconstruct a 3D shape and then determine which lines must appear in the incomplete views. Given three principal views with one or more views being incomplete, this means you are provided with front, top, and side views of an object, but at least one of these views is missing edges or lines. Your task is to figure out what lines should be added. Sketch the isometric pictorial and complete the partial view. To solve the missing lines, first, draw an isometric sketch, a 3D view. Second, use the 3D view to identify which edges exist on the actual object. And third, add those edges back into the incomplete orthographic views. These are three small drawings representing the three principal views. The top view, upper left, shows a rectangle with a vertical red line in the middle. This red line represents an edge to the top of the object. Next is the front view. From the bottom left, shows a shape with a slanted top surface. No red line is shown, meaning this view is incomplete. Next is the side view. The middle figure shows a rectangle with a horizontal red line inside. Again, this red line represents an edge on the object. These three views together describe the object, but some lines are missing and must be identified. The large drawing on the right is the isometric pictorial, which shows the actual 3D shape. You can see the slanted surface, the two red edges appear clearly, one on the slanted top plane, one on the vertical front face. These red edges match the red lines from the top and the side views. The isometric sketch helps you visualize the complete 3D object, understand where the lines truly belong. Use that understanding to complete missing lines in any incomplete 2D view. The next slide would be the general procedure. Step 1. Sketch the box for isometric view. Step 2. Choose a surface and identify its type. Step 3. Map surface to the pictorial. Step 4. Repeat for all surfaces. Step 5. Compare pictorial to all orthographic views. Step 6. Complete the orthographic views by adding missing lines. These steps guide you in creating an isometric 3D view and then using it to complete incomplete orthographic views. Now, let's tackle it one by one. For the step 1, sketch the box for isometric view. Start by drawing a basic isometric box that represents the overall size of the object. This box acts as a container where you will construct the shape. It helps you establish the height, width, and depth correctly. Next is the step 2. Choose a surface and identify its type. Pick one surface from the orthographic views. Identify whether it is principal surface type A, true size in one view, or inclined surface type B, slanted in two views, line in one. Or the third type is oblique surface type C, distorted in all views. This helps you know how to correctly draw the surface in 3D. Now for the next step, step 3, map surface to the pictorial. Transfer or project the chosen surface onto your isometric sketch. Draw the edges and angles of that surface inside the isometric box. Make sure the surface matches its appearance in the orthographic views. Now for the step 4, repeat for all surfaces. Continue adding one surface at a time. Slowly build the entire 3D object by mapping every visible surface. This ensures that final pictorial is complete and accurate. Now for the next slide is the step 5. Compare pictorial to all orthographic views. Check your isometric drawing and compare it with the front view, top view, and side view. Look for edges that exist in the isometric but are missing in the orthographic views. And now for the next slide is the step 6. Complete the orthographic views by adding missing lines. Add the missing edges to the incomplete views based on what you see in the isometric sketch. These lines represent edges of surfaces that were not shown before. This is the final step that completes the drawing. So in summary, this procedure helps you first build a 3D understanding of the object. Second, identify which line should appear in each orthographic view. And third, correctly add missing or hidden edges. So that's all for my report. Thank you for listening.